Part 14, exercise 3.3. अपन कर रहे थे exercise 3.3. Now question number 10. Suppose a girl throws a die. So she throws a die. Okay. Then if she gets 5 or 6, if she gets 5 or 6, okay, then she tosses a coin 3 times. Tosses a coin 3 times. Okay. And note the number of heads. If she gets 1, 2, 3, 4, if she gets 1, 2, 3, or 4, she tosses a coin once. Tosses a coin once. And note whether a head or tail is obtained. If she obtained exactly one head, what is the probability that she threw 1, 2, 3, or 4 with the die? So head. So when tossing a coin 3 times, so what is the probability of getting head? First of all, what is the probability of getting 5 or 6? That is E1. This event is what? E1 event, and this is event E2. The probability of E1 in throwing a die, 5 or 6 comes 2 times, and total possible cases are 6. So 1 by 3. And similarly, probability of E2, 1, 2, 3, 4 comes 4 times out of 6 total. So 2 by 3 and 1 by 3 times. Now tosses a coin 3 times. 3 times, so getting head, exactly one head. Okay. Tosses 3 times and notes the number of heads. So find the probability that exactly one head. So exactly one head. What are the conditions of getting exactly one head? Head, head, tail, 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 head, tail, head, tail, and tail, tail, head. These are the 3 conditions. So therefore, getting exactly one head is denoted by A. Suppose the probability of A when even is already happened is equal to 3 out of 8. Okay, got it? Okay. Now, if she throws a coin once, so exactly one head means probability of A when E2 has already happened is 1 by 2. Probability of head is 1 by 2. Here tail is also there, but no need of tail. And here also. So the question is based on that. So we have to find the probability of E2. E2 means 1, 2, 3, 4, getting 1, 2, 3, or 4 with the die, and if she obtained exactly one head. So E2 when A has already happened, A is exactly one head. So when probability that this is the probability that the girl to 1, 2, 3, or 4 with die if she obtained exactly exactly one head. Exactly one head. Okay. So what will be the probability? You know that probability of A stroke E2 into probability of E2 divided by probability of E1, probability of A when E1 has occurred already, plus probability of E2 and probability of A when E2 has happened. So this values, just substitute the values. 1 by 2 into 2 by 3 divided by 1 by 3 into 3 by 8 plus 2 by 3 into 1 by 2. So here we get 1 by 3 in the numerator, denominator 1 by 8 plus 1 by 3. So 1 by 3 into 3 is 24, 24, 8 plus 3, 11. 3 is 24, so 8 by 11 is the correct required answer. Question number 11, 13.3, question number 11. So there are three machine operators, A, B, and C. So operator A, operator B, operator C. And operator A produce 1% defective items. So E means producing defective item is E1 for operator A. So its probability is 1%. That means 1 by 100. The probability of producing the defective item by operator A, and probability of B is 5%. Probability of B producing the defective item is 5%, 5 by 100, and the probability of operator C to produce the defective items is 7 by 100. Okay. A is on the job for 50%. A is on the job for 50%. So probability of on the job is suppose denoted by A, but here already ABC is already there. So we can use another notation for the probability of the job. We can use J. Okay. Probability of the job when operator A is selected means by operator A is 50%. So 50 upon 100. Similarly, probability of doing the job by the sorry, this is not A1, E1, and similarly probability of job done by operator B is 30%. So 30 upon 100 is the probability. Similarly, for this operator, probability of yes, 20%. 20 by 100. Huh? So what is the probability that a defective item is produced by A? probability of defective item produced by A. That means probability of E1 J. So we can write probability of J stroke E1 into probability of E1 divided by probability of E1 into probability of job done by E1 plus probability of E2 to probability of E2 on the job in E on the job, then probability of E3 by Bayes theorem by Bayes theorem. Okay, now substitute the values. That is 50 by 100 or 1 by 100 into 50 by 100 divided by 1 by 100 into 50 by 100 plus 5 by 100 into 30 by 100 plus 7 by 100 into 20 by 100. All have LCM 10,000. 10,000 will cancel. 50. Here we get 50. 5 3 is 15. 150. 7 to the 14. 140. So total is 50 upon 340. So 5 by 34. This question is based on the cards, so it is somewhat different from other questions. A card from a pack of 52 cards is lost. From the remaining cards of the pack, 2 cards are drawn and are found to be diamond cards. Find a probability that lost card being a diamond card. Okay. So probability of lost card of diamond. E1, first we will say E1 is the probability of lost card is of diamond. The probability of one card, how many diamond cards are there? 13. There are 13 diamond cards out of 52. So 13 by 52. So 1 by 4. Probability of one diamond card. And if the card is not lost, what will be the probability of E2? That means probability of not losing the card is equal to, you can write 1 minus 1 by 4, 3 by 4 directly, or you can write by 39 by 52, because 39 cards are not diamond cards. So the lost card is not from diamond. So the lost card is from diamond is 13 by 52, and not from diamond is 3 by 4. As one diamond card is less than 12 diamond cards to be selected by, so one in this way one diamond card is lost. One diamond. Now if we go ahead, so one diamond card is lost. So when one diamond card is lost, how many diamond cards are left? 13. Out of 13, one is lost. So 12 diamond cards to be selected. Okay. So 12 diamond cards. That means out of 12 diamond cards, 2 cards can be selected, because you have to select second also diamond. So by how many ways? 12 C 2 ways. Can be selected by 12 C 2 ways. The probability of A even is getting diamond card. Second card is also diamond, is 12 C 2 cards, and 51 cards are left now. 51 C 2. So this will become 12 into 11 by 2 into 1, not writing. Will cancel with 51 into 50. Okay. Then now there is no diamond card lost. Here, no diamond card is lost. So therefore the probability of the second card to be a diamond card, first card is already drawn, which is not a diamond card. So how many diamond cards are here? Here all 13 diamond cards are there. 13 C2 upon, but one card is lost here also. So 51 C2. One card is not lost. Actually, we are doing without replacement. Just remember, when there is without replacement, here it is without replacement, not written, but you can understand by the question it is without replacement. So you can use the combination. Just remember always, when there is a without replacement, then we can use the combination 5C2, 4C2 without replacement. Okay, so that's why we used here. So this will be 13 into 12 upon 51 into 50. Okay,
Sir,
so
why is
probability
it
of
13?
the other card is also diamond. So diamond, the findability that the card that the card is being a diamond card. Hmm. So diamond, and then second also diamond, both are diamond card. Okay, so that will be from first one, because first card is also that diamond card which is lost. Second is also diamond card. Here other card is lost, so we have taken the other card, and that is lost. Lost means we are not putting back. One card is lost, that is without replacement. That's why we are using the combination. Okay, so E1 stroke A, they are asking the probability of A E1 into probability of E1 divided by probability of that formula E1 base theorem, probability of A stroke E1 plus probability of E2. Any doubt? E2 into probability of A stroke E2. Okay.
Okay, sir.
Any doubt with?
No, sir, I was asking why we took 13C2, but then I got.
Got it. 12 into 11 by 51 into 50 into 1 by 4 numerator. Okay, and denominator will be equal to 12 into 11 upon 51 into 50 into 1 by 4 plus 13 into 12 upon 51 into 50 into 3 by 4. Okay, to solve it, uh, you will get the answer 11 by 50. Probability that A speaks the truth is 4 by 5, then a coin is tossed, A reports that a head appears, probability that there was a head actually appeared. Find the probability. So speaks the truth is 4 by 5 and does not speaks the truth is 1 minus this, which is equal to 1 minus 1 minute. Coin is tossed, reports the head.
Head is top.
1 minus 4 by 5. 5 minus 4, 1 by 5, it should be 1 by 5. No, no, that's wrong.
There
That's
was
wrong. That's wrong. That's wrong. Speak the truth and does not speak the truth is 50%. Huh?
A speaks truth is
50% chances because
uh,
uh, exclusively and exhaustive events. So this is 1 by 2 chances to speak first speak the truth or does not speak the truth, and A speaks the truth. A speaks the truth, then a coin is tossed. So if he speaks the truth, suppose here speaks the truth, then coin is tossed and getting head H E1. Probability of getting head is for probability that A speaks the truth is 4 by 5. Will be 4 by 5. And coin is tossed. Here coin is tossed, then probability of getting head is 1 by 5. 1 minus 4 by 5. So 1 by 5. It is like this. Okay. So then probability of E1,
that actually there was a head. Probability
yes,
that actually there was head.
yes, there was a head.
I'm
So
sorry.
head we are finding. The probability of head when there was a head is this H E1 upon H from if he is actually there was a head means he speaks the truth. So this part E1 first part we have to use the first one. E1. You got it? Probability of so we get 4 by 5 into 1 by 2 upon 4 by 5 into 1 by 2 plus 1 by 2 into 1 by 5. So 10 is LCM. So 4 and here 4 plus 1. So 4 by 5. 4 by 5 is the probability that actually there was held when he speaks the truth. Last question. This is our last 14 question. 13.3 exercise. If A and B are two events such that A is a subset of B. When A is a subset of B, what will be the value of A intersection B? A is a subset of B. A is inside B. So their intersection will be equal to A. Okay. Then we can say that probability of A intersection B will be equal to probability of A, and probability of A when B has already happened, this equals to, you know, that probability of A intersection B divided by probability of B. This is our formula. And A intersection B is equal to PA. So PA will be equal to PB. And PB cannot be 0. When it cannot be 0, that means PB is a probability. This will be less than equal to 1. When it is less than equal to 1, then probability of A when B has happened will be greater than equal to PA. When denominator is less than, therefore this left side will be greater than this side. So therefore our answer is D. D is the correct option. Okay. So random variable hota hai, it is just like a function x. Do not confuse with this random variable. Random variable, it is a function. You can say it is just like when we put input. If we input the sample space points, sample space points, it gives us a real number. One real number will come. It is nothing to do with the probability. इसका probability से कोई ताल्लुक नहीं होता है ना. This is a random variable and it is already always defined in the question. Question में it is different for different question. It is defined in the given question. Okay. Yes, if for example, if we take an example of tossing two coins. Suppose we have an experiment of tossing two coins. So what are the possible outcomes in tossing the two coins? What will be our sample space? Head, 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 tail, 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 head, and head, tail, and head, tail. Okay. Now our suppose this x, when random variable is defined, suppose that in the question that x is a random variable defined as number of, in this experiment the random variable is number of heads minus number of tails. Number of heads and minus number of tails. So अब अपन देखेंगे कि how many random, what will be the value will be assigned for this random variable, because I told you that we are putting these sample spaces in this one and we are getting the real number according to this definition. So x head, head, so when both are head, 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 So random variable says the number of heads minus number of tails. So here how many heads are there? 2, and number of tails are 0. 2 minus 0, 2. So random variable has assigned the value 2. Okay, so always the random variable will get some real number, some value. This is not the probability. Okay, random variable is defined in the question. Accordingly, you have to find the random variable if it is given, but as you know that it is the deleted part, the last one, so maybe you will get the random variable and probability distribution you have to do, or it will be given and then you have to find the mean. Mean is also not there. So let's see that which type of questions can be asked now this year. So tail and tail. So how many heads are here? 0. Number of tails are 2. So we get -2. Then variable x when tail head. So how many heads are here? 1. How many tails are here? 1. 1 minus 1, 0. And when you have head tail, then also 1 minus 1, 0. So therefore the random variable assigns the values. How many values? We can say that x is a random variable which has got the values -2, 0 and 2. Okay, so this is called random variable. So before finding the probability distribution, we have to find the random variable that we have done. So how will you find the random variable? Definition will be given in the question. Okay, and accordingly you have to put the sample space and find the random variable. Okay, got it? Now probability distribution. How to find the probability distribution? Okay, so random variable, we can make the table for random variable and then find for each random variable we have to find the probability. Okay, so for -2, 0 and 2, these are the 3 random variables. For them we have to find the probability. Px, probability of -2, probability when random variable is -2, probability when random variable is 0, probability when random variable is -2. So what will be the probability when -2 is coming? Means -2 means 2 heads. 2 heads. Sorry, -2 is here. No head, 0. -2 in -2 cases. In -2, there is only one case when you are getting -2. That is tail tail. Okay, tail tail. So one case you are getting when you have -2. So 1 by 4. Total possible cases are 4, and tail tail. This will give you the -2 random variable -2. Correct. So 1 by 4. Then 0, but 0 we are getting in the 2 cases, tail head and head tail. In 2 cases we are getting the 0, so 2 by 4. And for 2 we are getting only in one case when head will come together, then we get the random variable 2. So one case only 1 by 4. Now the most important thing is you have to remember that for probability distribution, this all should come 1, means 1 by 4 plus 2 by 4 plus 1 by 4 is equal to 4 by 4 is equal to 1. If this is not equal to 1, then this is not a probability distribution. So two conditions are there compulsory for checking the probability distribution. So just remember, for probability distribution, one is obvious, that if we call this one P1, P2,
Sir, can
P3,
you
so
define
let's
probability
say
distribution?
Pi. So this Pi, you know that the probability of, yes, what? With
Sir, can you
Obed,
define probability distribution then?
probability distribution is the probability of finding the variable 2. Means when the variable 2 comes, what will be the probability? How many outcomes are favorable to giving the random variable as 2, the value of 2. When the value of 2 of the random variable is coming to, then in how many cases, that out of, there are in a sample space, how many possible cases are there? 4. So how many cases are giving the random variable 2? In how many cases you will input in this formula, in this function, and you get 2? So how many cases are there? Only one case, head. Got it? So 1 by 4. And
Okay,
how
sir.
many cases you are getting -2? Only tail, and tail will give you -2. So this is also one case, so 1 by 4, and this is also 1 by 4. I have written here. And how many cases are giving 0? Two cases. Okay, in two cases you are getting the value of random variable as 0, so therefore two cases. So out of 4 there are two favorable cases. The number of favorable cases which are assigned to give the value of random variable, okay, divided by total number of possible cases. Got it? So for any
Yes, sir.
probability distribution, it is compulsory. This sum should be equal to, the sum of all these numbers should be equal to 1. So there are two conditions. All probabilities should be greater than 1 or greater than 0 and less than 1. That is obviously, you know that. Second thing is their summation. You can say the summation of PIs, all PIs should be equal to 1. Summation of all these probabilities should be equal to 1. For example, here P1, P2, P3 is equal to 1. This is suppose P1, and this is P2, and this is P3. So their sum should be equal to 1. Then it is called probability distribution. Otherwise, it is not a probability distribution. Okay. So we have seen the random variable and probability distribution. So after random variable, we can find the probability distribution, and in the starting, you will be getting this table, and you have to find whether the given distribution is a probability distribution or not. So in that case, you have to check first check all the probabilities should be less than 1 and positive, and second thing you will check their sum should be equal to 1. If these two conditions are followed, then it is a probability distribution. Otherwise it is not a probability distribution. Okay, then mean. What is mean? Mean is denoted by here mu, or we can use ex, expectation, because mean is also known as expectation, ex. So mean is the summation of all these. This is Xi's, all Xi's, and multiply with pi's, their sum of the product of xi into pi, xi into pi. For example, here if I want to find the mean, so what is xi here? Minus 2 into 1 by 4, correct? -2 into 1 by 4, plus second is 0 into 1, there is 0 into 2 by 4, sum of their products, 2 into 1 by 4, but we are getting 0. This is called mean. So while after finding this, you can make one more column for finding this one. This column, you can make one more column for finding this xi into pi, which is the product of these two numbers, and then you can find here summation. Okay, got it? So this is mean. So before mean, you should know the random variable and their probabilities. Then you can find out the mean. Okay. Then variance and standard deviation. So that we studied in class 11, that variance of this x formula is, you can write direct formula, because the proofs are not going to be asked. So, and also it is a deleted portion, you are saying, so minus e expectations whole square. This is the formula of finding the variance. So what is Ex square? X square means where you have to multiply, first find xi square, okay, xi square. Here you are getting minus 2 into 4, minus 2 into 4 and 0 and 2 upon 4. Now xi square, 2 square is 4, 0, 2 square is 4, and this will be xi square pi. Multiply, and this summation, this will be the summation which will represent Ex square. Ex square is what? Square of x multiply with the probability, that 4 into 1 by 4, 4 into 1 by 4, and 0 square is 0, and 2 square is 4 again, 4 into 1 by 4. So that is coming 2. So here if you will put 2's, 2 minus this is 0 whole square. So variance you are getting 2. And what is standard deviation? If you remember, standard deviation is sigma, and standard deviation is the square root of variance. In 11th class we studied. So you can find under root 2 will be the standard deviation. SD is equal to under root 2 1.414. This is all about the rest of the part in 2 exercises: random variable, probability distribution, mean expectation, variance, and standard deviation. Hope you understood. Agya, got it? A very easy type of questions
Yes,
you
sir.
have in the starting. करना है continue और hello
Sir,
बोलो.
Yes, sir, you're audible.
sir, continue.
नहीं continue करना है क्या और
Okay, sir. If everyone is okay with it.
So we
Sir,
can
could
do
you
it later, sir. Actually, I have some work right now. मेरे को जाना होगा बाहर.